Greetings to Dr. Azahar. This is Group 4, presenting ultrasonic testing. So I'll be the presenter for part 1. My name is Cornelia Anak Colin, and in this section I'll be talking about general introduction of ultrasonic testing, the basic principle of sound waves, ultrasonic waves generation, piezoelectric materials for ultrasonic transducers, and types of ultrasonic transducers. So what is ultrasonic testing? It is one of the most popular NDT techniques using beams of mechanical waves that can travel large distances in fine-grained metal. It can detect internal hidden discontinuities that may be deep below the surface. The center frequencies ranging from 0.1 to 15 MHz and sometimes up to 50 MHz. And one common application is the ultrasonic thickness measurement. It is often performed on steel, alloys, concrete, wood, and etc. And the common industries are steel and aluminum construction, metallurgy, manufacturing, aerospace, and automotive. The basic principle of sound waves. Sound waves is a form of mechanical energy as it travels in a longitudinal wave in a series of compressions and rarefactions. Ultrasound is considered those frequencies greater than 20 kHz which cannot be heard by human, as human hearing has a limited range of 20 Hz to 20 kHz only. So ultrasonic waves are very similar to light wave as they can be reflected, refracted, and focused. So this section I'll be talking about how ultrasonic waves are generated. For generation of ultrasonic waves, frequencies of mechanical vibration above 200 kHz, piezoelectric transducers are used. For analysis or tests, all mechanical vibration are generated by these transducers that can be converted into mechanical energy and vice versa. Piezoelectric transducer consists of different types of materials that have different functions and different advantage. So in this next section, I'll be talking about what types of materials using piezoelectric transducers in this technique. So the first one is quartz transducers. It is most widely used because of its high stability, insolubility, chemical inertness, resistance to aging, and ability to withstand high temperatures. But it has a low output that can keep up with the latest technologies. So they changed into barium titanate. So in the early 1950s, quartz crystals are changed into this man-made ceramic as it is one of the most effective ultrasonic generating material due to its ability manufacturing in wide variety of shapes and size, have operating efficiently at low voltage and operate at very high temperatures to 300 degrees Celsius. However, it is a poor receiver of ultrasonic waves because if it's strained, it produces a much lower voltage as compared to a voltage would have been produced. So the third one is the lead zirconate titanate or PZT. It is a polycrystalline material that can be polarized by applying a strong electric field. And the good thing about this, the impedance is very low as compared to natural piezoelectric crystals like the quartz. So the last section I'll be talking about is what other types of ultrasonic transducers are used mainly. So the first one is the straight beam contact, and it is typically used for scanning parts with regular geometry and relatively smooth contact surface. So there are two types. First, the first electrode have crystals and the other one are exposed. And the next type is the electrodes are provided on both sides and it is protected by acrylic perspex to shield the piezoelectric crystals from breaking. The second one is the angle beam contact. It is used in inspection areas that have a certain angle and used in inspection of pipes, tubes, forgings, castings, etc. And typically used to introduce a refracted shear wave into the test material. The third one will be paintbrush transducers, as it is used to scan wide areas, and this transducer is smaller and more sensitive because it's to further define the details of discontinuity or the break in the material. And the last one will be delay line transducers. And this can introduce a time delay between the generation of the sound wave and the arrival of any reflected wave to allow the transducer to complete its sending function before it starts to listen function, so that near surface resolution is improved. So this is designed to have high precision thickness gauging of thin materials and delamination checks in composite materials. That will be all for my part.
Hello guys, we continue with the part 2. My name is Ifna Ifanamila binti Sariman. My name is Ifanamila. So in this part, you will get further knowledge about the ultrasonic testing. There's a few topics that I will cover. So the first one is the types of ultrasonic wave. So we have 4 principal modes. The first one is longitudinal wave, second transverse wave, third surface wave, and the last one is plate wave. And then, okay, for the first one is longitudinal wave. This one is the most mode that have been used in ultrasonic testing. You can see the figure above. The particle movement is parallel with the propagation of longitudinal wave. Okay, sometimes they also call it density wave because material density fluctuates as the wave moves. So this one is compression and expansion. So the compression wave can usually be generated in gases, liquid, as well as solid. So we continue with the transverse wave, also known as shear wave. It is also that has been used, most mode that have been used in ultrasonic testing. So you can see the bottom one. The particle oscillates at a right angle to the direction of the propagation. Usually, it is not effectively propagated in material like liquid or gases, only solid, and it is weaker when compared to longitudinal wave. So the third one we have surface wave. This one is like it moves like elliptical motion, where it is combined of the longitudinal and transverse. So this surface wave travel at the surface at a solid that penetrating to a depth of 1 wavelength. It is very sensitive to the surface defects and they follow the surface around curve. That's why they are very good in a certain area that have been difficult to reach. So the last one we have plate wave. Okay, this one the difference with the surface wave they are penetrate with a few wavelength. It is inside thin plate. So you can see that they are propagate parallel to the test surface, this one, throughout the thickness of the material. And it is influenced a great deal by the test wave frequency and material thickness. So with the length wave, a number of mode particle vibration are possible, but the two most common are symmetrical and asymmetrical. So the first one is symmetrical. So this one, if they move in symmetrical fashion about the median of the plate, they propagate parallel to the test surface throughout the thickness, also called extension mode. And then the last one we have asymmetrical lamp. Okay, in this mode the body plate bends as the two surfaces move in the same direction. They also called flexural mode. Okay, get those waves keep flowing. We continue with the properties of acoustic wave. So this formula is very familiar. Oh, I'm sorry. Lambda equal to V over frequency. I know that we all know wavelength, velocity, and frequency. So wavelength is inversely proportional with the frequency, and usually the velocity, if it's because of the medium, have their own characteristic. So when the frequency increase, the lambda also increase. And then we have wavelength and defect detection. So what is sensitivity? Is the ability to locate small discontinuities. So when the sensitivity increase, frequency increase, the wavelength also increase. Resolution, the ability of the system to locate discontinuities that are close together within the material. So when the resolution increase, the frequency also increase. These are the factors of the inspection. And then we continue with the materials properties that affect the speed of the sound. Okay, this one is the general relationship between the speed of sound in a solid, the density, and the elastic constant. You can see that this is the formula. And then I continue. Okay, they have their own specific formula. In velocity, in the longitudinal wave, these are the formula. E is the Young modulus. MV, you can see that this one is Poisson ratio, and we have transverse wave, the velocity one. Ng is the shear modulus of electricity. And then we continue with the attenuation of sound waves. Okay, the combined effect of the attenuation their meaning is the combined effect of scattering and absorption. attenuation is generally proportional to the sum of frequency. These are the formula: A equal to A naught, e to power of negative AZ. And then I continue with the last one, acoustic impedance. Okay, this one is about that sound travel to material under the influence of sound pressure because molecular or atom elastically bound together. And then this one, they have their own formula. This one Z equal to density and velocity. Okay, acoustic impedance is important because they can in the determination of acoustic transmission and reflection at the boundary of two material, the design of ultrasonic transducer, and assessing absorption of sound.
Assalamualaikum. My name is Siti Aisyah binti Zubair. I'm a third year medical physics student and I'll be presenting the third part of ultrasonic testing. In this part, I'll be presenting about reflection and transmission coefficients, test techniques, and locating discontinuities. For reflection and transmission coefficients, reflection of ultrasonic waves that occurs at boundaries is due to the impedance mismatch. Impedance mismatch is the difference when there is a difference occurs between acoustic impedances, which we denote as Z. Below is how we calculate the reflection coefficient. Z1 and Z2 are the acoustic impedances of two materials. This is transmission coefficient. We simply calculate by this equation. Next is test techniques. There are four techniques under ultrasonic testing. There are pulse echo, transmission, immersion, and detection of discontinuities. For pulse echo, transducer will transmit a short pulse containing a few oscillations. When ultrasonic pulse that incident on defects, a portion of pulse wave is reflected back from the flawed surface. The wave is reflected to the receiver, converts into electrical signal, and displayed on the screen. This method accurately determines the distance from the surface of the object. Transmission technique use a pair of ultrasonic probes, which one act as receiver and the other one act as transmitter. Ultrasonic waves are transmitted as continuous oscillations or short pulses. The sound wave that is incident on the discontinuity, the received sound energy will be less. For immersion technique, it is done by placing the test object and the transducer in a water-filled tank. An echo from front surface of the object is displayed in the signal. Water acts as a couplant that removes the variability of coupling quality that may occur in contact inspection. For detection of discontinuity, the probe is moved evenly to and fro across the part surface. Signals caused by reflections from internal discontinuities are observed. There is a near field area and a far field area. The portion of sound wave which comes back to the probe after being reflected by the discontinuity is mainly depends on the direction of the sound wave. The plane discontinuity can be detected better when it is hit vertically by the sound beam. Angle reflection is used for vertical crack detection. Tandem technique is used to test thick wall object for vertical discontinuities and is effective. It uses two probes and the depth or the part depends on the probe spacing. Selection of the scanning angle and the test frequency are also vital for the single probe test. This is how the signals look like for pulse echo technique and transmission technique. This is the bottom echo and this is the defect echo. This is the signal from immersion technique. These are the diagram for detection of discontinuities. There are straight beam probe and angle beam probe. And this is the near field area and the far field area. This is the method of detecting the discontinuities. Next is locating discontinuities. There are normal beam inspection and angle beam inspection. Normal beam inspection, we can simply calculate the location or the distance of discontinuity by this formula. D is the distance from surface to the continuity, from surface to discontinuity in the specimen. V is the velocity of sound wave in material. T is the time measured during a round trip of sound wave. For angle beam inspection, it is done when angle beam transducer or wedge is used. It is for effective flaws detection in and around welding. This is how we calculate the flaw depth for angle beam inspection. That's a wrap for part 3. Thank you for participating.
This is the last part for this video. Before that, I want to introduce myself. My name is Nur Sakinah, year in medical physics, the last presenter for this video. There are 4 points in my part. The first one is the inspection application of ultrasonic testing, such as estimation of grain size in metals, erosion and corrosion, and flaw detection, and etc. The next one is the common applications of ultrasonic testing inspection. There are 5 that I have listed. The first one is thickness gauging, that is routinely utilized in the petrochemical and utility industries to determine various degrees of corrosion and erosion. The second one is cast work pipes. Defects in materials which occur during casting are pipings, cavities or porous sites, segregation, and others. Both shear and compression techniques are widely used for examination of castings. These are the common defects in castings. The third one is the welded work pieces. The defects occur because the fusion phases do not melt properly or blend with the filler metal, or lack of penetration and lack of fusion defects. Most welds fall into one of the following categories. The first one is the butt weld. Next is the T-weld. The last one is the nozzle weld. Other than for welded, ultrasonic testing inspection are commonly used to inspect rolled products such as tube testing. And the last one, ultrasonic testing inspection can also detect non-metallic materials, for example the concrete, is by determining a false velocity in concrete. My second point for this video is the 3 types of signal presentation. The first one is the A-scan. Is the most commonly used signal presentation. The horizontal line indicates the elapsed time and the vertical deflection shows the echo amplitude. Second is the B-scan. For B-scan presentation, the echo intensity is often indicated semi-quantitatively by the relative brightness of echo indications on an oscilloscope screen. This is the system setup of B-scan. B-scan presentation is widely used in medical applications, and the optimal results can be obtained using small transducers and high frequencies. And the last one is the C-scan. Display records of echoes from the internal portion of test pieces as a function of the position of each reflecting interface within an area. This is an example of computer process. This is the system setup of C-scan. Important for C-scan is the electronic depth gauge. That is the electronic circuit that allows only those echo signals that are received within a limited range of delay times following the initial pulse or interface echo to be admitted to the receiver amplifier circuit. And these are some of the advantages of ultrasonic testing: detailed images, instantaneous results, minimal part preparation, high accuracy, only single-sided access, depth of penetration is superior and sensitive to both surface and subsurface discontinuities. And these are the few limitations of ultrasonic testings. The first one is the surface must be accessible to transmit ultrasound. Skill and training is more extensive and normally requires a coupling medium to promote transfer of sound energy and There are 4 steps to obtain National Skills Certificate for Non-Destructive Testing. The applicants must pass vision test, complete theoretical and practical training, pass NDT qualification assessment, and complete industrial experience durations. And this is the hours needed for training for ultrasonic testings in Malaysia. And these are the syllabus for ultrasonic testing based on the IAEA. In Malaysia, these are the few NDT accredited centers such as Agency Nuclear Malaysia, Syrian Berhad, and etc. And this is the ultrasonic testing courses that offer for this year from the accredited agencies in Malaysia. And this is the list of national occupational skills that is offered in different area for ultrasonic testing. For example, oil and gas, underwater, and aerospace. And that's all from Group 4. Thank you.